Hello students, in previous video we have seen enthalpies of physical changes. Today we are going to discuss about thermochemistry. What is thermochemistry? A branch of chemistry. A branch of chemistry which deals with enthalpy changes or heat changes during a chemical reaction. Is called thermochemistry. A chemical reaction may be either exothermic or endothermic reaction. Exothermic reaction takes place with liberation of heat and endothermic reaction with absorption of heat. That means enthalpy change takes place during a chemical reaction, and thermochemistry is a branch of chemistry which deals with enthalpy changes or heat changes taking place during the chemical reaction. Now, what is enthalpy of chemical reaction? The difference between the sum of enthalpies of products and the sum of enthalpies of reactants. Difference between sum of enthalpies of products and sum of enthalpies of reactants with each substance in its definite physical state and their amounts in terms of moles as represented in a balanced chemical reaction. It is called enthalpy of reaction. What is the enthalpy of chemical reaction? The difference between sum of enthalpies of products minus sum of enthalpies of reactants with each substance in its definite physical state and their amounts in terms of moles as per the balanced chemical equation. It is called enthalpy of chemical reaction. It is denoted by delta RH. Now, how it is explained? Now, first of all, Before that, you can see formula for enthalpy of reaction. Delta Ra is nothing but summation of enthalpy of products minus summation of enthalpy of reactants. This is formula for enthalpy of reaction. Now it is to be explained with the help of general reaction. Consider a general reaction. A moles of A plus B moles of B to give C moles of C and D moles of D, and we have to determine enthalpy of this reaction. Suppose H is enthalpy of reactant A per mole. Hb is enthalpy of reactant B per mole. Sc enthalpy of product C per mole. And Hd is enthalpy of product D per mole. Here all these are to be put with same units along with signs. HA, HB, SC, HD. All these are enthalpies. They are to be put in the formula along with their signs and same units. All are either in joules or all in kilojoules. Now, formula for enthalpy of reaction is same. Summation of enthalpy of products minus summation of enthalpies of reactants. As per this balance equation, you can calculate enthalpy of this reaction as now products are C and D. Now C moles of C, that means C into Sc. This gives total enthalpy of product C plus D moles into enthalpy of D. This bracket gives total enthalpy of product D minus now reactants A into HA. This product gives total enthalpy of reactant A as per the equation plus B into Hb. This bracket gives total enthalpy of reactant B. Now along with signs and with same units, these values will be put in this formula. You will get like this, or enthalpy of reaction gives this this is bracket for products minus bracket for reactants, and finally you will get the answer. This is a way of solving problems on enthalpy of any chemical reaction. Now next point we have to discuss about types of reactions and their corresponding enthalpy changes. First about exothermic reaction. What is exothermic reaction? A reaction which takes place with liberation of heat. It is called exothermic reaction. A chemical reaction which takes place with liberation of heat or evolution of heat, it is called exothermic reaction. How it is explained? Exothermic reaction takes place with liberation of heat. Heat is evolved during exothermic reaction. Exothermic reaction is always favored by low temperature. As in exothermic reaction, as enthalpy of products is less than enthalpy of reactants, change in enthalpy change delta RH is always negative. This is, now you can cite an example for exothermic reaction. For example, decomposition of KClO3. 2 moles of KClO3 decompose to give 2 moles of solid KCl and 3 moles of oxygen gas. This is one of the reactions, and here it is exothermic reaction, and therefore enthalpy change of this reaction is shown by negative sign, minus 78 kilojoule. This is enthalpy, and it is an example of exothermic reaction. Now next point we have to discuss about endothermic reactions. What is endothermic reaction? A reaction which takes place with or takes place by absorption of heat. Absorption of heat. It is called endothermic reaction. A reaction which takes place by absorption of heat. It is called endothermic reaction. How it is explained? Endothermic reaction takes place by absorption of heat. Second point. Endothermic reaction is favored by high temperature. And third point. In endothermic reaction, as Hp is greater than HR, enthalpy of reaction delta RH is always negative or always positive. That means delta RH positive. A reaction which takes place by absorption of heat is called endothermic reaction. In endothermic reaction, it is absorbed by the system and it is favored by high temperature. In endothermic reaction, enthalpy of products is greater than that of enthalpy of reactant, and therefore enthalpy of endothermic reaction is always positive, delta RH positive. Example: say for example, this reaction N2 plus O2, both gases, they form nitric oxide gas. Enthalpy of this reaction is plus 66.4 kilojoule. This is about exothermic and endothermic reaction. Now next point we have to discuss about thermodynamic standard state. What is thermodynamic standard state? A thermodynamic state in which substance is more stable. A state in which the substance is most stable under the conditions such as pressure, 1 bar pressure, (25°C) means 298 Kelvin temperature, and 1 molar concentration for solutions. If substance is treated or involved, substances are involved in the reaction under these conditions at 1 bar pressure, 298 Kelvin temperature, and concentration of the species 1 molar. This state is supposed to be thermodynamically standard state. Now here, if question is asked, what are the conditions for thermodynamic standard state? You have to mention these states: pressure 1 bar, temperature 298 Kelvin, and concentration 1 molar. Now there are some examples. Under standard state, H2, H2 gas, Hg liquid, sodium solid, carbon solid or graphite, or also it is in gaseous state. All these are elements in their standard physical states at 1 bar pressure, 298 Kelvin temperature. There are some compounds also. C2H5OH in liquid state, calcium carbonate, CaCO3 in solid state, CO2 gas, H2O liquid. These are the compounds in their standard physical states at 1 bar pressure at 298 Kelvin temperature. Now we have to discuss about standard enthalpy of a reaction. By following these standard conditions, you can define and explain standard enthalpy of a reaction. Standard enthalpy of a reaction, or it is also called standard rate of reaction. It is denoted as delta RH naught. Here naught or 0 on the top of the H indicates standard conditions. 1 bar pressure, 298 Kelvin temperature, and concentration 1 molar. How it is defined? It is also difference between sum of enthalpy your standard enthalpy of products and standard enthalpies of products and the pressure of 1 bar and temperature of 298 Kelvin and concentration of the species 1 molar with every substance or every species in its standard physical state. It is called standard enthalpy of the reaction. What is standard enthalpy of reaction? The difference between sum of enthalpies of products and the sum of enthalpies of reactants. Here mistakenly I have written product. The difference between sum of standard enthalpies of products and the sum of standard enthalpies of reactants at pressure of 1 bar, temperature of 298 Kelvin and concentration of the species 1 molar with every species in its standard physical state. It is called standard enthalpy of reaction. Now what is formula? Standard enthalpy of reaction delta R H naught is summation of standard enthalpies of products minus summation of standard enthalpy of reactants. This is the formula. If you consider a general reaction explanation, consider a general reaction in which A moles of reactant A combines with B moles of reactant B to give C moles of product C and D moles of product D, and we have to determine standard enthalpy of this reaction. Now formula is same. Delta RH naught is equal to summation of standard enthalpy of products minus summation of standard enthalpy of reactants. Now you put the values. Here you can have Aj naught, H naught A, it is standard enthalpy of reactant A per mole. Standard enthalpy of B, H naught B, it is standard enthalpy of reactant B D per mole. Then H naught C, it is standard enthalpy of product C per mole. And finally H naught D, it is standard enthalpy of product D per mole. Here all with same units. Along with sign, you have to put in the formula H naught B, H naught A, H naught B, H naught C and H naught D all must be in same units, and values of these must be put along with signs in the formula. Now, how it is calculated? Now here standard enthalpy of reaction is given by this formula. Now, as per the balance equation, you have to put the values. Delta H naught is equal to C, number of moles of product C, into standard enthalpy of C gives total enthalpy of product C, plus D into standard enthalpy of D. This bracket gives total enthalpy of product D, minus A into standard enthalpy of A. This product gives total enthalpy of reactant A in the equation, plus B into standard enthalpy of B. This bracket gives total enthalpy of reactant B involved in the reaction. Delta R H naught, it is calculated like this. Delta RH naught will be equal to, this is total enthalpy of products minus this is total enthalpy of reactant, and finally you will get enthalpy change of the reaction along with sign. This is a way to calculate standard enthalpy of reaction. Now next point we have to discuss about in this respect. It is about thermochemical equation. You are familiar with balanced chemical equation, in which certain moles of reactants are present and they give certain moles of products. Here, what is thermochemical equation? Definition: a balanced chemical equation in which enthalpy change physical states and number of moles reactants and products are specified. It is called thermochemical equation. A balanced chemical equation in which enthalpy change, delta H, physical states of reactants and products such as solid, liquid, gas or aqueous medium and number of moles of reactants and products are mentioned. It is called thermochemical equation. Thermochemical equation can be written by following some guidelines. Therefore, next point we have to discuss about guidelines to write thermochemical equation. Question may be asked, what are the guidelines or rules used to write thermochemical equation on paper? First guideline, thermochemical equation must be balanced. Consider the balance chemical equation with respect to number of moles of reactants and products. This is first rule. That means thermochemical equation must be balanced. Second, the value and appropriate sign of enthalpy change. Enthalpy change delta H naught or H is to be given on right hand side of the equation. This is second rule. Once you write balanced chemical reaction, you write corresponding enthalpy change with proper sign and unit on the right hand side of the equation. Third, standard physical states of the reactants and products are given in brackets by small letters such as small s for solid, small l for liquid, small g for gas and small aq for aqueous medium. This is is third rule. That means you must mention standard physical states of reactants and products in brackets before them by small letters. Small s for solid, small n for liquid, small g for gas, aq for aqueous medium. Here, aqueous medium is not to be balanced because water is present in excess. It is not to be balanced. Fourth point of rule: value of delta RH naught written on RHS side of the equation shows that reaction takes place spontaneously. In forward direction. Forward direction. If reaction is reversed, sign of delta RH naught must be reversed. Sign of delta RH written on right hand side indicates that reaction takes place in forward direction. If you want to reverse this reaction, you have to reverse sign of enthalpy also. If previous sign is positive for endothermic reaction, if reaction is reversed, it becomes exothermic and sign of delta H becomes negative. In case of exothermic reaction, previous sign of enthalpy is negative. If you reverse this reaction, it becomes endothermic and sign of the delta H becomes negative, exothermic. Alright. That means if exothermic reaction is reversed, it becomes endothermic and sign changes from negative to positive. If reaction is endothermic and it is reversed, it becomes exothermic. That means if previous sign is positive, on reversing the reaction, it becomes negative. This is fourth rule. And fifth rule: thermochemical equations. Can be multiplied or divided like algebraic equations. That means number of moles of reactants and products can be multiplied or divided by any numerical factor or number. Thermochemical equations can be multiplied or divided by any integer. And here, during multiplication or division of thermochemical equation by any number, you have to also multiply or divide enthalpy change by that number. This is important. There are some examples of thermochemical equations which are written by following these rules. First, CH4 gas plus 2O2 gas to give CO2 gas plus 2H2O liquid. This is one reaction, and if delta RH naught is given here, minus 890 kilojoule, this becomes thermochemical equation. Here, this is balanced chemical equation. Standard physical states of reactants and products are mentioned. Enthalpy change with proper value and sign is given on right hand side of the equation. If you multiply this equation by 2, it becomes 2CH4 gas plus 4O2 gas to give 2CO2 gas plus 4H2O liquid. That means this first equation is multiplied by 2. That means you have to multiply enthalpy of first reaction also by 2. That means new enthalpy of this reaction becomes minus 1780 kilojoule. If you multiply 890 by 2, you will get this one. Then, if you divide this equation by 2, if you divide equation 1 by 2, you will get 1 half CH4 gas plus O2 gas to give 1 half CO2 gas plus H2O liquid. That means you have to divide this quantity by 2. Then you will get enthalpy of this new reaction as minus 445 kilojoule. That means in these three examples almost all the guidelines are followed to write these equations. This is about thermochemical equation. In next video, we will discuss about standard enthalpies of formation, standard enthalpies of combustion, and after these units we will try to solve some numericals on enthalpy of reaction, enthalpy of formation, enthalpy of combustion under standard conditions and some other conditions also. Thank you.